Okay, hello everyone. Good morning. Thank you for joining today's session. My name is Kelly. The other presenter for this session is Leonardo. We are all coming from Linaro. And today's session is about the Linaro's technical update on openEuler. This aims to provide an overall picture of the Linaro's effort on this excellent operating system. Okay. So today's agenda, we will provide a very rapid snapshot of openEuler's dynamics, and then with a brief introduction of Linaro's collaboration with openEuler, follows with the technical update in the major collaboration areas. Sorry. Yeah. Sorry. Not the page. Okay. So for openEuler, then after the first release in 2019, openEuler has already been a pivotal force in the global ecosystem of the open source operating system. It is positioned as a digital infrastructure OS. It is designed to support diverse application scenarios to support such as server, cloud computing, edge, and embedded system. It supports multiple processor architectures, and focus on the delivering secure, stable, and user-friendly OS ecosystem. Here are some numbers listed here for the brilliant achievements for openEuler till this year. One of the important is that from the official claims and the community consensus, the openEuler 24.03 LTS is recognized as the world's first AI native open source operating system. So, okay. Then Linaro started a collaboration with openEuler from the beginning of the journey. Linaro and openEuler's community partners together, they contributed in various key technical features on the ARM64 ecosystem, such as the high-performance acceleration technologies and solutions, big data and data science, confidential computing, software-defined storage, etc. openEuler is just like a bigger umbrella. Nearly all the collaboration and contributions going through various openEuler SIGs. So this diagram renders a high-level view of the collaboration and achievements. One key focus here is that how to make openEuler widely adopted by and synergize with the influential open source project and the communities. And we also worked on the pursuing of performance and security, such as how to utilize the hardware accelerator, how to support the security feature provided by the architecture. So for the high-performance acceleration technology and the solutions, this refers to the UADK project. It's the User Space Accelerator Development Kit. It is designed to leverage the heterogeneous computing capabilities, which for the performance-critical tasks such as compression, decompression, encryption, decryption, AI workloads. All of this requires low latency data processing. UADK just simplifies the accelerator integration and provides a unified solution and framework while maximizing the computing efficiency in the heterogeneous system. Meanwhile, in the community, there are many typical projects. They contain the performance-critical tasks, which we have mentioned above. Such projects like openSSL, DPDK, NGX, etc. They are naturally the exploring areas to co-work with UDK and utilize it. So this page highlights some major milestones for the project, such as the first UACCE implementation in the kernel and more algorithms supported by UADK. We also implemented the OpenSSL engine or provider extension. So this allows the OpenSSL to utilize the hardware accelerator capability, hardware acceleration capabilities, such as the Kunpeng accelerator, and for its cryptographic operation via a standardized interface, OpenSSL integrate with UADK with its accelerated algorithm, such as the AES SM4, and this significantly boosts the performance for the protocols like HTTPS or TLS. And for other milestones like the SPDK and the DPDK, so we also, the integration with the UADK also achieved the latency reduction and the throughput improvement. So what is going on now? That we are continue the upstream work of the VSVA patches. This try to enable the Gatsby VM to utilize the hardware accelerator. So most of the patches are already merged, and still one need to be in 6.16. For related QML patches, lots of them are still in the debugging branch. So we need to think about and discuss with community for the strategy. Then the live migration is a vital feature in the dynamic cloud environment. The key question is how to make live migration work with a direct assigned hardware accelerator. We have made some early investigation. This is still ongoing. Then for the library enhancement, we are working on the heterogeneous scheduling solution. Why this is needed? The current UADK support both the hardware accelerator and the CPU instruction acceleration, but both of them have their own performance advantage for different workloads. For example, the CPU instruction acceleration is more friendly to small packet size, while the hardware accelerator performs better with a big packet size. But the workload is dynamic, and these two methods are not able to work together and or switch freely between them. So this comes the requirement to support the coexistence of multiple heterogeneous accelerators or accelerations for the sake of the performance. Linaro developed the initial implementation by introducing the concept of worker as the basic schedule unit, together with a few of scheduling mode. But the community has other solutions. Both the solutions are now under performance evaluation. So for the next step, we may think about to support the no SVA mode to refine the framework, and later to support more accelerators. Linaro contributed to big data and data science area, started with the Apache BigTop project. It is a big data ecosystem integration and validation platform focus on the unifying building framework for the Hadoop in ecosystem. It addresses the fragmentation issues prevalent across the big data components through the unified packaging, the capability testing, and the automated deployment. It serves as a foundational infrastructure cornerstone of the big data ecosystem. So for the milestones, the BigTop 3.3.0 release natively support openEuler in July last year. So this marks the upstream community recognition of the openEuler compatibility with the big data ecosystem. Linaro will continue the contribution to BigTop 3.4.0 release, which is planned by the end of this year. And to have a more deeper integration with the big data projects, Apache BigTop Manager project was created to optimize the deployment, orchestration, and management of the big data stack through a standardized automation. This BigTop Manager 1.0.0 was officially released in this April. And this year, we started some work with gluten and vlogs. This combination is very hot in the big data ecosystem. So gluten is designed to boost the performance in GVM-based big data system by integrating them with native vectorized execution engines. While vlogs is just such a vectorized execution engine designed to accelerate data processing workload by enabling hardware native optimizations. Generally, gluten translates or offloads the workloads on top of vlogs and utilize the vlogs hardware native optimization. And this greatly boosts the performance. And through this translation or offloading, then gluten extends the integration with the heterogeneous, with integration with the hardware heterogeneous capabilities. For both the project, we are in the early stage, started with the community CI support, and this is still ongoing. And for the next step, will be the supporting openEuler and to investigate the room for performance improvement. Okay. For next topic, I would like to relate to Linaro.
Thank you, Kelly. All right, so yeah, Kelly presented two of the projects that we have been working with Huawei and the openEuler community. Another one is software-defined storage, which is contributed mainly by Xin Liang and Kevin. They are here if you have real technical questions after the presentation. So software-defined storage basically. There was a gap a few years ago, and a number of the famous, storage frameworks used by, cloud deployments were not really ported to ARM yet. So Linaro has been working not only porting these projects to ARM64, but also integrating them into openEuler, right? So this is an example of the projects that we have worked in the past. So Ceph, Maya Data, or MyStore, I think that was the name before, Lustre, BGFS, DAOs. So the objective was really to decrease the gap between ARM64 and x86 servers. But not all, we ported, we integrated into openEuler, and we also worked on performance optimization. So if you look at what we accomplished so far, you will see that, as I mentioned, we have enabled projects on ARM64. We introduced them to openEuler in various versions, and we also worked on performance optimization because sometimes these projects, of course, were built for x86 servers, so they really don't have any kind of optimizations on ARM. And in the future, we are, today we are working on JuiceFS. So for whoever doesn't know what JuiceFS is, which was my case a few months ago, it's a storage file system mainly used for AI workloads. It runs on top of other storage frameworks such as Ceph, for instance. We have ported it to ARM64, integrated to openEuler, and now we are doing, Xin Liang is doing some performance evaluation to see if there are any changes that we need to introduce to improve the performance. And after that, our focus for the rest of this year will be mainly on SPDK and investigating the performance on vhost and VFIO user, towards the end of the year. We know there are some issues there, and we plan to, fix them. Right? That's it for software-defined storage. And the other project that is actually probably the largest project under the data center group that I am the lead of inside Linaro is confidential computing enablement on ARM64. So this is a huge effort that started 2.5 years ago, more or less. The objective of this project is to actually enable confidential computing architecture, or CCA, that was mentioned by Mike Brossell in his keynote, in a way that we have a reference implementation, that can go from hardware emulation up until to container deployments, so that anyone in the ARM64 community can leverage the power of confidential computing to protect their workloads. And inside this project, I mean, of course, this is a very big mission, right? And as I said, we have been working on this for more than 2 years now, but we are also making sure that all the pieces we are building are integrated into openEuler. openEuler has confidential computing SIG, but not only the confidential computing SIG is involved. I think the kernel SIG, right, the container SIG, I mean, they are all working together to make sure that the things we are producing here as a reference software stack can be integrated in all the pieces needed inside openEuler as well. And yeah, I mean, the final objective is, of course, to provide an end-to-end solution that works on openEuler. Right, so these are just the deliverables that we had specifically related to openEuler. If you are curious about what we accomplished in general in the CCA project inside Linaro, I will give a presentation on that 2 slots from now in some room. I need to figure out. This one? Okay. Meeting room number 3. Thanks, Jonathan. But again, I mean, that will cover everything that we are doing on the CCA project. These are the things that we did in the past year, targeting the openEuler community, right? So mainly really creating the repository, building stuff, adding support to SecGear, which is the solution for configuring confidential computing on openEuler. Thanks, Kevin, for confirming. And we are now, we just integrated the openEuler attestation service to include CCA token attestation support, right, last month. This is the roadmap of the project going forward. Again, this is not only related to openEuler, this is a very broad project. We are working, as you can see, on containers, right, Kata confidential containers. We are enabling RME 1.1 features. There will be a talk from ARM in the next session at meeting room 3 as well from Dan Henley. Huh? Is in the keynote? Oh, yeah, of course, he's more important. So, oh, I am in the keynote as well? Ooh, okay. So anyway, he will be talking about the roadmap for CCA, so you will hear, if you are interested, a lot about RME 1.1, what are the features, what is the roadmap to enable these features, and we are deeply involved in this work. And I think that's it. Yeah, thank you. Any questions?
Thanks for the talk. It was very interesting. In terms of AI workloads on openEuler, I know often the focus is on Huawei hardware, but are you also targeting non-Huawei hardware on openEuler? And if yes, what are some of the other platforms you test on?
Well, openEuler runs on other hardware platforms. I know x86 for sure.
In terms of ARM, I'm more interested.
Well, okay, in terms of ARM, it runs. I mean, I can tell you, I mean, I see people running Debian and other distros on, sorry, it's the opposite, right? You don't want, so I saw people running openEuler on various ARM machines. That's not a problem. It's just the standard kernel, it doesn't have anything that is different from other distros. Yeah, it should work. I mean, I know there is an interest from Huawei to expand, let's say, the support of openEuler in different hardware platforms, right? Unfortunately, the geopolitical situation is not helping a lot, but yeah, it's definitely one of their objectives.
Thanks.
So there have been a lot said about the accomplishments in the openEuler projects. What are the current challenges and problems there?
So all these projects, they are long running. So we, as I mentioned what we're doing on JuiceFS, right, and SPDK. For the big data, it's really defining the content for the next big top release for this year. The community is slowly progressing in the past 2 years after some shakeups that happened and people moving around. So we are trying to, make sure that the community return to have focus and a good roadmap or a healthy roadmap that can deliver new features. And UADK, I don't know. I don't know if Zhao has any more idea about what are the challenges on UADK in the near future, or Kelly. It really depends. Do you know, Jonathan? So you can speak up.
So there's a bunch of complexities. We've been talking to some of the QEMU folk around how we do the VMM modeling for the VSVA stuff, and how you map it to SMMUs matching the correct devices on the physical machine. And that's kind of the biggest blocker for the VSVA bit, which is sat under UADK for the virtualized side of things. And that's, it's tricky. There's going to be some arguments there. It may take a while.
Yeah, and for CCA, there is a bunch of things to be done. Yeah. So there are plenty of challenges ahead, and openEuler and Huawei have been good collaborators with Linaro. So we plan to continue like that.
I'd just add there's a massively long tail of software. It's a sort of list in priority order, which Linaro are doing some of, and there's others happening elsewhere. And it'll take an awful long time before we run out of things to do. Whether they're specific challenges, it's kind of just too many things to do.
Any other questions? All right. Thank you very much. See you around.